Section 2.4 exercises. We wish to write the equation of a line that passes through a given point. Here it's negative 2, 5. But it must be parallel to another line whose equation is y equals 3x plus 1. Well, parallel lines have the same slope. And since the equation is y equals 3x plus 1, we know that the slope is 3. So our line, whose equation is y equals mx plus b, or y minus y1 equal m times x minus x1, must also have a slope of 3. Now we're asked for point slope form, so we'll use this one right here. We already know the point that our line goes through, and we know the x and the y. So we'll substitute all that in. Function minus the y value, 5, equals the slope of our line, which must be 3 since it's parallel to the other line, times the variable x minus the x coordinate of negative 2. And that is our point slope equation of the line. For slope-intercept form, we can simply slowly solve this equation for y, and we will end up with our slope-intercept form rather than start over. So I took the opposite of negative 2 to be plus 2. Now we'll distribute through 3 times x plus 3 times 2, and then we'll add 5 to both sides, giving us our final result in slope-intercept form, y equals 3x plus 11. Problem 2. Write the equation of a line through a point that is perpendicular to another line, and we have its equation, and this time it's in general form. So we'll take our equation of the other line, and we need to find the slope because perpendicular lines have slopes that are negative reciprocals. So we need to get the slope of our line, and we'll solve for y to do that. So taking the x to the other side and the 12 to the other side, and then dividing by 3, negative 1/3 times x plus 4. So the slope of this given line is negative 1/3. The slope of our line is the negative reciprocal, so we flip over 1/3 to give us 3, and the negative of that will be positive 3. And we wish to express our equation in both point slope form and in general form. So in point slope form, we'll have y minus the y value, which is negative 6, is equal to the slope 3 times x minus the x value, negative 2. And we'll have to simplify that, and we'll arrive in slope-intercept form. And we'll decide along the way how to put this in general form. Again, general form is the way this line is written. Y plus 6 is equal to 3x. This is x plus 2. So 2 times 3 is 6. And we have a bonus here that subtracting 6 would make it go away on both sides, giving us only y equals 3x. To write in general form, we want the x value first, and then the y value, and then the constant, and always equal to 0. So we'll bring the y value on this side, giving us 3x minus y is equal to 0. And there we have our general form. Problem number 3. We have 2 points, and we wish to find the slope of the line through those points and explain what it represents. So we have our variable x representing our time, and we have our function y representing a million men who are living alone. So we'll first grab the slope formula and do the computation there. So 14.7 minus 9 divided by 2008 minus 1990. Doing the arithmetic here, we'll end up with 5.7 divided by 18, which is decimal 32. So since the slope indicates the change in million of men living alone divided by the time in years, then this means that the number of men living alone is, well, it's increasing because our slope is positive, and it's increasing by 0.32. The units are the units for the function, which are million men, divided by the units for the variable, so we'll say per year. The number of men living alone is increasing by 0.32 million men per year, or we could say 320,000. Last problem, number 4. Find the average rate of change from first value of x to the second value of x. The average rate of change is really just the slope, but it works for curves and not just for lines. So I'll write this in function notation. It's the y value at the second value of x minus the y value at the first value of x divided by the corresponding change in those x values. That should look like the slope formula. So we need to compute the y value at 0. F of 0 is 0 cubed or 0. And we need to compute the y value at 1. F of 1 is 1 cubed or 1. So to find the slope there, we take the change in the y values, 1 minus 0, divided by the change in x values, also 1 minus 0, and we get a slope value of 1. And this is the average rate of change. Let's repeat that same calculation for different set of values from x equals 1 to x equals 2. So f of 1 we know from before is 1, and f of 2, at the second value, is 2 cubed or 8. So the average rate of change is the difference in the y values divided by the difference in the x values, and that is 7 divided by 1, or 7. And that concludes the problem set for section 2.4.